think about it when I get there.
Okay. The coefficient of variation is another way at looking at variability within samples. The coefficient of variation, or CV, is the standard deviation divided by the mean and expressed as a percentage. And what this allows us to do is to make comparisons of the variability of different samples that is independent of the units in which those samples are measured in. For example, the coefficient of growth rate is 15%, but progesterone levels are more variable with a coefficient of variation of 30%.
Often you'll see reference to percentiles and quartiles. A percentile is a value below which a given percentage of observations fall.
The quartiles are similar, but they're defined by fractions rather than percentages.
Sometimes you'll see reference to a percentile range. In this example, the values that define the range are the 10% and the 90% centiles. So this range excludes the lowest 10% and the highest 10% of your observations. And if you think about what we were discussing concerning outliers, this means that the range will be more robust and less affected by these outliers.
The interquartile range, then, is defined by the values of the 25% and the 75% centiles. In other words, it contains the middle 50% of the observations that we're looking at.
Moving on to graphical representations, here we have something which is called a QQ plot. Sometimes you'll see PP plots. Basically what these do is they graph what we know about the percentiles against what we know about the percentage distribution of observations throughout the normal distribution. If we get a straight line with our observations clustered very closely around that straight line, we can assume that we have a normal distribution. If we get major deviations from the straight line, we know that there is something strange going on in our data and can investigate that a little bit further. Box and whisker diagrams are a very good way of looking at our data. They summarize data within each sample using 5 major observations. First of all, we have the maximum value and the minimum value and the median. Then we have the upper quartile, the 25% of observations which are above the median, and the lower quartile, the 25% of observations which are below the median. It will also indicate if you have any outliers in your data set, as shown here. So if we go back and have a look at the full box and whisker diagram, the sample number 1 on the left looks nicely balanced. The median value, the bold line in the center, is central, and the various quartiles are evenly distributed on either side. Sample 2, the middle sample, looks as though it might have a left-hand skew. The range of observations below the median are wider than the range of observations above the median. And then finally, the third sample looks as though it might have a right-hand skew. The range of observations above the median are much wider than the range of observations below the median. And one thing that we'll be demonstrating is how you can use statistical methods to do tests to see whether these deviations are important or not.
Finally, we'll deal with data transformation, and that's what to do if the data are not normally distributed. And in this case, what we need to do is transform the data. And what that means is, instead of analysing the raw data we actually convert it to some other scale and analyze that. For example, we might take the square root of each of the values and then analyze the square root values, because what we find is that data is transformed in this way often follows a normal distribution.